Hello, let's try to understand radian. It is a measurement of angle, right? First, let me just draw an angle here, kind of like this. So, in an angle, there are two arms, one and the other. And this is called the vertex. Let me say, call it by letter V, okay? And normally, when we draw an angle, we call this side as the initial side. And we call the other arm as a terminal side. Right. So the starting position is kind of like this. Imagine that this arm, the second terminal side, is resting on the initial side. Let's say it's here. So what we do is we just move it in a circular way with the vertex being the center. And as you move like this, it makes an angular arc, and if you just completely draw it with this vertex, it will form a circle with radius r. Let us say this is radius r, okay? So let's say that we rotate this point P from here to here with the vertex at V. And let us say that this distance from here to the point P is r. So we will call that as radius of our circle, or in this position we are just showing an arc, okay? And in that case, the angle subtended at the center, or the central angle, this is at the center. So, and this is our arc. We'll say arc, let arc be A, and let this angle be theta. We use this Greek letter theta very often to show the angle. Okay, so what we did was we took an arm along the side of initial side with the radius of r, and we rotated it in which direction? Counterclockwise. We rotated it counterclockwise, and now let us say that it comes to position Q. So when it comes to position Q, at that time A is our arc, and let's say A is the length of this arc, correct? And at that point, let the angle formed by the two arms, one the initial side, the other one be the terminal side, let that angle be theta. Okay. Now, we will try to develop a relation between theta and the arc length A. Okay. Now, let us say that if we increase theta, let's say we go further on and move from this position to a position like this. So what happens? As theta increases, the arc length also increases, correct? If we increase it more, let's say like this, the arc length increases further. So what we see is that arc A is proportional to angle theta. What I'm trying to say here is, as theta increases, A increases, right? It works either other way also. If I decrease theta, if I bring terminal arm closer to the initial arm, in that case arc length will decrease. So it's both ways. So that's one kind of thing which we observe here. Another thing we observe here is, let us assume that we take a longer arm. So let's say this is R, and let's take another arm which is longer. So let me draw that longer arm. I can draw it here itself. Let's say this is my longer arm, right? For same theta, for the constant theta, you will notice that for capital R, let's say this longer arm is capital R. In that case, my arc length capital A is much bigger. Do you see that? What I'm trying to say here is, in the first case, if angle increases, arc increases, keeping R constants, radius constant. Here at this time, my radius R was constant. Correct? Now this time, let us keep this theta constant. In that case, we observe as r increases, my arc length also increases. That means A is proportional to radius if theta is constant. Correct? So as r increases, A also increases. Okay. Similar to, let me show you one example, distance, speed and time. Remember distance, speed and time? Let me write it on the side how distance, speed and time work together. You know distance? Distance is proportional to time. Let us say if speed is constant, right? If you are driving at a speed of, let us say, 60 kilometers per hour, more time you drive, more distance you cover. Similarly, distance is also proportional to speed for constant time, right? Where t is constant, is okay? And here where speed is constant, right? Correct? So, in distance time we found a relation, like we could make a triangle like this, and we said, well, in distance time terms, distance is proportional to time and speed, and therefore distance is equals to speed into time. Correct? That is, if you are driving at 60 kilometers per hour and if you drive for 5 hours, distance covered will be 60 into 5. Correct? Measurements showed that same kind of relationship is possible here also. Arc length, this is the arc length, is proportional to theta if this radius is constant. Right? Did you see that? Yes. Let's say radius is r, then as I increase theta, my arc length also increases. Now, if I keep theta constant and increase the radius, then as I increase radius, my arc increases, correct? So, by experimenting, it found out that this relation can also be written as A equals to r times theta. Now, this relation gave rise to theta in radians. And from here, we say, see what happens if I put r as 1. If r equals to 1, then what happens? Then A equals to theta. Perfect, right? So, what is theta? Theta is the angle subtended by this arc at the center, or the central angle. Do you see that theta in the center? So, that gives us the basic definition of theta. And we call this theta as measurement of an angle, and the unit was radians. So we say 1 radian. Now theta equals to arc length, so 1 radian of angle is equal to what? Is equal to length of the arc, arc length, for radius of 1 unit. Does it make sense? If r is 1, then arc length is equal to theta, the angle. And we call this angle as 1 radian. Okay? So that's the basic definition of 1 radian, and that's how we understand radian. It is length of the arc when radius is 1. Now what are its units? Okay, we'll simplify this relation here to find the units. So we wrote A equals to r times theta. That means theta equals to what? We can divide by r both sides, correct? In that case we get theta equals to A over r. Now for units, what is the, let's say A is a length, right? So let's say length is in centimeters, and r is also length. Let's say it is also in centimeters. So if it is centimeter, they cancel out. So basically theta is a ratio of lengths. So it doesn't have any particular unit. It just, we have named a unit as radian, but in true sense, it is not centimeter or centimeter over centimeter or something else. It is actually without any unit. right? It's a ratio. Okay. So that is how we came up with theta and its definition. Do you appreciate it? So theta equals to A divided by R from here, this relationship. So that gives us another definition of theta, and that is the radian measure of an angle theta is defined as the length A of the arc that subtends the angle divided by radius r of the circle. Because if we continue to make this, it will make a circle of radius r. Okay, so theta is the ratio of arc length to radius in a circle. Correct? So that's the simplest form in which we can say what theta is. Correct? So I hope you understand theta by now. Now, think about this. If I make one full circle, then what is the value of A? So the question here is, let us say one full circle, right? So find A for full circle, that means circumference, right? So what is circumference of a circle? We know circumference is 2 pi r, right? Circumference is 2 pi r, correct? So if the circumference of a circle is, let's say this is a circle, if the circumference of the circle is 2 pi r, what is the arc length? Arc length is circumference, right? So A is 2 pi r for one full circle. Do you understand? A is 2 pi r for one full circle. And by definition, what is theta? Theta is the value of A for r equals to 1. Correct? So if I put r equals to 1, then what is A? That implies A equals to 2 pi. So for a full circle, what is theta? Theta is 2 pi. Theta equals to 2 pi for full circle. Do you understand? In degrees, what is theta for full circle? 360 degrees, right? Which is 360 degrees. Do you understand? So from here, we also get one more important relation, and that is 2 pi radians equals to 360 degrees. Or what is pi radians equals to? We can divide both by 2, or we say pi radians equals to 180 degrees. So that's another relationship about between pi radians equals to 180 degrees, correct? So we can use this formula to convert degrees to radians and radians to degree, and we will see that in the next video. Okay, I hope you understand the concept behind theta, the angle subtended by an arc in the center. Okay, and that angle is equal to the length of the arc if radius is 1 unit. It could be any units. In fact, radian we say as unit of the angle theta, but actually speaking it's just a ratio. And if you go for full circle, as you know, circumference of a circle is 2 pi r, and that means a arc length will be 2 pi r for full circle, right? If you start from here, go like this, full circle, A will be 2 pi r. And definition of theta says theta is A, the angle subtended in the center is A, provided r is 1. So if I put r as 1, I get A equals to 2 pi, that means theta is 2 pi. So for a full circle in radians, what is the angle? The angle is 2 pi. Just as in degrees, we have angle of 360 degrees. Correct? So we learned a couple of things here. First, we also related our angle theta to in radians to degrees. Correct? Secondly, we related it to arc length when the radius is 1. I hope you remember that, and we'll do some questions which will help you to get this concept. Thank you.